In today's video, I'm going to run you through the three basic calculations in moles for solids, liquids, gases. Let's take a look. In this lesson, I am going to introduce to you the moles formulae that you will come across in GCSE chemistry, as well as grade 9, grade 10 chemistry if you're in the US, and how to use those formulae depending on the question being asked. So, in science, we have solids, liquids, and gases. And for each state of matter, there is a moles formula. So let's take a look at what they are. So for solids, the moles is equal to mass over the relative formula mass of the molecule. The mass has to be in grams. Then for liquids, moles is equal to the concentration times the volume. So C is concentration, and the standard units for concentration are always moles per decimeter cubed. And then the volume is always in decimeter cubes, which means if you were using this formula and you were supplied with information about something, a solution that is in centimeter cubed, you have to remember to convert from centimeter cubed into decimeter cubed before you plug it into this formula above. And 1,000 centimeter cubed is 1 decimeter cubed, which is also known as a litre. So 1,000 centimeter cubed, 1 decimeter cubed, or 1 litre is the same thing. Okay, so must remember to put the volume in decimeter cubed. And then finally, specifically at 25 degrees C only, so that's the condition here for this, the moles of any gas is the volume of that gas divided by 24. So again, V is volume, and that's in decimeter cubed. And that formula comes from the approximation that 1 mole of any gas, whether that's hydrogen, oxygen, carbon dioxide, whatever, occupies approximately 24 decimeter cubed volume. So that, if you're thinking where's the 24 come from, that's what it is. So these are the three basic formulae that you will be using in your high school studies. And sort of how do you know which one to use? Well, it will actually tell you very explicitly in the question. So in terms of state symbols, solids have an S, liquids will be L or AQ, and then gases is a G. So when you're looking at a chemical equation and you've got the state symbols there, that's going to tell you what state of matter, and then you can proceed and use the formula required. So if the question is talking about a mass, then you're going to be using the solids formula. If it's talking about solutions, like for example acid-base reactions, then you're going to be probably using the moles equals CV formula. And then if it's talking about gases being produced, maybe hydrogen's being produced when a metal dissolves in an acid, or there could be a combustion reaction like a hydrocarbon, maybe methane combusting with oxygen to produce CO2, then you're going to be using the gas formula. Or you could actually be using all three at the same time for a chemical reaction that has solids, liquids, and gases all in the same equation. I mean, that's really common as well. So let's take a look at a couple of basic examples below. Before we start, make sure you have your calculator and periodic table to hand. And let's take a look. So, when do I use the solids formula? So the question will mention mass, right? It will say find the maximum mass, what mass? And then that's the solids formula. So let's do this one. So moles equals mass over RFM. Then rearrange, we'll give mass equals moles times RFM. And then the moles we're told is 3.4. And the RFM, well, we have to work that out. So sodium has an atomic mass of 23. So it's 23 plus another 23. And then oxygen is 16. So grab your calculator. Let's do this together. So 3.4 times brackets 23 plus 23 plus the 16 gives us to 1 decimal place, 210.8 grams. So used to the solids formula, you're looking for the word mass being used in the question. I know this might seem kind of obvious, but it's very common for students to get confused about which formula should I use. Right, when do I use the liquids formula, or by extension, when the term solution is mentioned? So again, the most common occurrence of this is going to be an acid-base reaction, an acid plus a base producing a salt and water, and then you've got to find an unknown concentration. So let's take a look at this one. Find the concentration of, or find the volume of, any mention of these terms, then you're going to be using this one, moles equals CV. So for this one, we've got to work out, we've got the moles of 20 centimeter cubed of 0.2 molar HCl. So let's work that out. So the concentration is 0.2. And the volume, you will see that it's 20 centimeter cubed. So I have to turn that into decimeter cubed first before I can use it. So that's 0.02. You must remember to do that, otherwise your answer will be out by a factor of 1,000. So we've got moles equals C times V, which is 0.2 times 0.02 gives us an answer of 4 times 10 to the minus 3 moles. So to use the solution formula, the concentration formula, again, the question will talk about find the concentration of, or find the volume of, and it'll be liquids reacting in the equation. Finally then would be an example of a gas. So let's look at this one. Now we'll mention volume. Now you've got to be really careful that you don't use the concentration formula by mistake. In the example I mentioned above, and that you specifically use the gas formulae when presented with this sort of question. So find the volume of gas liberated when 2.5 grams of ammonium chloride decomposes to produce HCl and NH3 gas. Or another one would be, what is the volume of carbon dioxide produced when 50 grams of calcium carbonate decomposes? So actually, let's take a look at the equations for these two reactions. So NH4Cl decomposes to produce HCl gas plus NH3 gas. And then calcium carbonate decomposition, that's CaCO3. You blast it with a Bunsen burner and it decomposes and you get the calcium oxide being produced. And carbon dioxide comes off as an effervescence. So if we take, let's try this second one. So we've got 50 grams of calcium carbonate. And how do we work out the volume of CO2 being produced? So this one is a little bit more involved because it involves something called the 3-point process, which I've covered in another video, and is the basis for all of the molar calculations, but I'll do it here anyway. So, and then you can check out the video in the link below. So the first thing you have to do is you've got to work out the moles of calcium carbonate reactant first of all. And you will see we are given the mass in grams there, right? So what do I use? I have to use the solids formula. So moles of calcium carbonate will equal mass over RFM. And then we put that number in, so it'll be 50 divided by calcium is 40 plus carbon is 12 plus oxygen is 3 times 16. So we have 50 divided by 40 plus 12 plus 48. And that gives me an answer of 0.5. So 0.5 moles of calcium carbonate has been decomposed. The next thing we do is the molar ratio between the reactant and the product. So if I circle, that's the reactant, that's the product we're interested in. And if you look at the link there, we can see the molar ratio is 1:1 in this case. 1 lot of calcium carbonate produces 1 lot of CO2. How do I know it's 1:1? Because there's no balancing numbers before it. So it's just a 1:1 ratio. Okay, so there's no 2 or a 3. So that's what I know. So therefore, the moles of CO2 produced is going to be exactly the same. It's also 0.5. Right, finally, step 3 of this 3-point process, again, I've attached the document below, is to find what is asked for in the question. So we have been asked for the volume of carbon dioxide. So I need to use the gas formula. So moles equals V over 24. Rearranging, V equals moles times 24. And now I'm going to plug the numbers in. So the moles of carbon dioxide produced is 0.5 times 24 is going to give me an answer of 12 decimeter cubed, or in other words 12,000 centimeter cubed. Okay, so for this reaction, if you decompose 50 grams of calcium carbonate, you're going to get 12 decimeter cubed of carbon dioxide produced. Now that last example was harder, right? And like I said, it brings together all of the moles formulas as one sort of complete question. Now, please, the perfect follow-up to today's video is to check out all the links below where I go through more of these examples using all of the different formulas at the same time. And it sort of gives you a complete picture of the types of question you could be asked. Anyway, that is it. I hope you've found some value in this. If you've got any questions, comment down below and I'll get back to you and help you. Otherwise, I will see you in the next one.